Good afternoon. Well, depending on where you are, good afternoon, good morning, good evening. And welcome to our seventh Solidity stream, where we're going to be focusing on the JavaScript library, not just JavaScript, but also embedding Solidity inside JavaScript or Node or Dino. So really exciting stream today. I'm joined by Misha. We'll be talking about the JavaScript library, the TypeScript bindings that we've been working on lately, and also the WebAssembly library itself. If some of you don't know what that is, we'll be talking a little bit about what that is and what you can do with that in today's stream. Of course, we'll be answering any questions you've got, whether that's to do with JavaScript. That's a good one for this stream. But obviously, we did a big merge of a pull request by Emmanuel yesterday, which is related to indexing and full text search indexes. So if you've got questions about full text search indexing or any other questions or anything else, we'll try to answer them as best we can. So Misha, welcome, and
Hello.
great to have you here. Talk to us a little bit about what you've been working on over the last couple of weeks, and about the latest release with regards to WebAssembly and what is it?
So yeah, we've been pushing a lot of updates to the JavaScript library the last few weeks. A lot of it was built by the community, which we're very happy with, of course. But it wasn't perfect. So essentially, what we did is we turned around a lot of things, and we made some big improvements, and we shipped them over the last few weeks. There were some bugs, and we fixed them again. So that's all live now. And then also last week, we published the first version of the WebAssembly library, which we're very excited about, of course. So essentially what WebAssembly allows you to do is it allows you to completely run like native code, for example, C or Rust in our case, of course, completely in the browser. So what you can do with this is you can grab Solidity and you can compile it into WebAssembly. And at that point, you can either completely run that in the browser, or you can, like in memory, you can run it with IndexedDB, so it will stay persistent across sessions. You can also use it to connect to a existing Solidity instance with the binary protocol, which obviously is more performant than the text WebSocket protocol.
Hey, that sounds brilliant, and we'll dive into that a little bit more, and with regards to what features that enables or what use cases that enables as well. Jumping back a little bit to the improvements to the standard JavaScript and TypeScript library, I guess that's a good starting point so that people can understand the differences between that and the WebAssembly library. But talk to us a little bit about the changes that you've made and what that results in for the JavaScript and the TypeScript ecosystem.
So the changes were mostly done when it comes to typing for TypeScript, because it is a TypeScript library which you can also use in Node.js, Dino, or just vanilla JavaScript. Most of the changes were done when it comes to typings and internal restructuring. So the typings were made a bit more. I don't want to say easy, because inherently the typing for specifically the query function is just a bit difficult to comprehend. Because you can, for example, run multiple queries, and those multiple queries can all return different results in different formats. So we tried to make that a bit easier and a bit more understandable. Besides that, we renamed some functions because we renamed them upstream and we want to make them ready for the future. And there was a lot of internal restructuring. Before, there were a lot of event handlers that were catching up other requests, sort of. And it all fell back into like a huge list of steps that I had to go through before the data came back from Solidity to you, the developer. And we shortened that path, which makes it easier to debug errors and makes it easier and faster, obviously, to retrieve data.
That's awesome. Before we carry on, I guess the the name of this stream is the JavaScript library with Misha and Toby. So in addition to the JavaScript client SDK, we've got a question here from the community. Sophia, thank you for the question. So Sophia has asked on YouTube about the PR that they've made regards to array-based functions to ThurlQL. So JavaScript focused, but not a client library, but actually the embedded library. So Sophia, thank you for that. We will, first of all, that PR is brilliant. I was looking at it just this morning, and hopefully we'll be merging that this week as well. Yes, but definitely we're going to talk about the embedded JavaScript runtime a little bit as well later on in this stream, and that should answer your questions about what we see happening with that. But definitely, thanks for that question. We'll answer it properly in a little bit when we turn to the embedded runtime a little bit. So Misha, I know you've got a little bit of a. So we actually only released the WebAssembly library last week, and we've been ironing out some bugs for the first version this week still as well. And the official first version for that will be coming with our beta 10 release. But Misha, I know you've got a demo that you've together just in the last 30 minutes. So
Absolutely.
Let's look at what exactly we can do with the WebAssembly library, and I'll bring the screen up now.
So yeah, what you can see here is it's just a little code pen that's running in the browser. So there's a little demo here. It's basically a very simple reminder app. You have a list of reminders. You can edit them, and you can save them again, or you can also delete them. And you can also create new reminders. So it's a very basic app, but the nice thing about it is that it completely runs in the browser with the WebAssembly library. And if we go ahead and take a look at the code, you can see that we're importing Thurl from unpkg here. So it's basically a CDN for NPM, which allows you to import any NPM package via a public URL. We got some React here to make it a little bit easier to develop the app. So what happens is we're initializing a Thurl instance here, and we're connecting to it via a memory instance, as it were. Then we select a namespace and a database to use, just like we do in the JS library. And well, you will see that the WebAssembly library, that the API is actually very similar to the JS library. So we're defining some tables and some fields here for this demo. And this was a funny thing because I was creating some demo data for the application, and I was like, what? I'm adding the date and everything, and the items keep reordering in different orders while I'm selecting them based on the date. But it turns out that it is so fast that it just does it with like in microseconds. So I
was going to say that's interesting. Not something I realized. To note on that one, because JavaScript doesn't have any concept of nanoseconds in its time API or date time API, as opposed to its performance timing API. When our records get created in nanoseconds or microseconds, they also get classed as the same millisecond in JavaScript. So they all happen at the same time. That's interesting.
Yeah, so essentially what I had to do there is I had to create a little wait function that will wait 10 milliseconds every time that I'm inserting a record to ensure that it will, stay in order. So that was an interesting thing to find out last minute. But yeah, we're just inserting some demo data here, and that's it for initializing the ThurlDB instance.
So Misha, what can you do with the WebAssembly library that you can't do with the JavaScript and TypeScript libraries?
There is actually a thing that you cannot do with the JS library at this moment. So what you can do with the WASM library is you can, obviously completely run ThurlDB in the browser. That's for one, but the way that you query your data, you can use the range selection with the WASM library. This is because it, in the end, comes back to the Rust code, and the Rust code will interpret that range, and it will query that to the database. And we currently cannot do that with the JS library
Excellent. And I guess we've got users using us in Deno, in Node.js, and in the browser, of course. Maybe potentially some people using us in Bun and other JavaScript runtimes. When using us in Node.js and Deno, let's say, does it offer persistence? As in, can we use this as we would a traditional database like LevelDB, or even when connecting to something like MySQL or Postgres or MongoDB?
You know what? I haven't actually tried that just yet. So I can't really answer that, to be honest. But surely it will be possible.
Let's. So in the browser, we can use IndexedDB. Your second task there. Have you tried? Obviously, this is early days for the library, but have you tried connecting to IndexedDB as a backing database, so that when you refresh the page, the data is still there?
I wanted to do it here. I tried it here, but I think that due to some iframe restrictions or the way the CodePen works, it didn't work here. Yeah, it just wouldn't render. So, but normally you would be able to do that. So that's the reason that I'm using memory here. But normally you could definitely use IndexedDB. Yeah,
makes sense. Okay, fine. So there'll be restrictions on the web page. That's a good point. I mean, this is awesome. So, kind of, what's the roadmap for the WebAssembly library and the JavaScript libraries going forward?
Well, there will mainly be coming changes to the WebAssembly library still, because obviously there are still some bugs that we need to iron out. For one thing, we definitely need to greatly improve the typings. It's very limited right now with just a lot of any, and eventually in the end we would like to completely put it straight with the JS library, so that you can basically just use it as a drop-in replacement and use it that way.
That was going to be my next question. So it should literally, by changing the URL that you're importing from, or the package you're importing from, it should be able to just be lifted out and plopped in with a WebAssembly plugin. Is that correct?
Exactly. Yeah. At some point, not right now, but in the soon future. Yeah.
Brilliant. We've got a question here with regards to the WebAssembly library from Avinash. Can images and videos be stored in the browser WebAssembly database instance?
I mean, you could use the byte types, like the bytes types, which I think is introduced in Beta 9. Not sure how performant it will be, though.
Yeah, it's a good question. We don't actually support images and videos storage in SerialDB just yet, Avinash. But obviously, one way to make that work is you store your images or videos in S3 or Google Cloud Storage, or locally on the instance, and then you store the metadata in SerialDB itself. But we are looking to improve that. We've got a feature request on GitHub for adding file storage within the transactions. So that's the more complicated aspect that we're trying to work out. We've got that feature request, and we will look to get that into SerialDB in the future. So effectively, what we want the WebAssembly library to be it gives you as a developer the ability to run SerialDB locally, whether that's on the server side or in the browser, and have all or almost all of the functionality that you have when you run it as a server. So that's where we're going to. Baral, yes, this stream is recorded. It should be on YouTube once it's finished. So, Misha, as Sophia asked the question about the internal JavaScript runtime, I think we should turn to that a little bit. So obviously, Misha was or is still a big user of the embedded JavaScript functions, and you can do a lot of cool stuff with them. But obviously, there is a performance hit. So Sophia's question was, do we see it as a fallback or as a core feature in SerilDB? And that's an interesting question. I think posing that to Misha a little bit. Obviously, we want to have some improve the functionality in SerilQL so that you can do more in SerilQL, but you can do some pretty advanced things in the JavaScript functions that we may not support in SerilQL itself, can't you? What are some of the things you've been doing with the embedded JavaScript functions?
So it's mainly to currently change data in a sense, because array functions are a little bit limiting right now. And thanks, Sophia, definitely for opening that PR, by the way. Really much appreciated. But so that's one of the things that I've been using it for, to change data in a way that's currently not possible with SerilQL. But there is an amazing PR open by Mace, who just joined SerilDB. He is implementing fetch right now into the JS runtime, which is going to be pretty cool, to say the least. So and there will be many more things coming to the JS ecosystem within SerilDB in the near future, which will make it a real game changer.
Interesting. Yeah. So Sophia, we definitely see the JavaScript embedded runtime as a core feature, but really it's as an extension of SerilQL. With SerilQL, we want that to be powerful. So if you're dealing with array-based data, and obviously in SerilQL you can have objects and arrays in your records. So therefore, we do want SerilQL to have additional performance and additional functionality around arrays and handling those arrays. So the PR that you made with regards to array-based functions is awesome, and if it helps people move away from JavaScript and get that extra performance, then that's even better. But definitely, JavaScript functions are seen as a core feature for anything beyond what SerilQL can do, whether that's making requests to a Stripe API or accepting a form input and passing it off to the database or to another API remotely. These are all things that we probably wouldn't support in SerilQL directly. Especially, I think it was Misha actually who added the feature request for supporting form inputs and sending of forms. But it's the API for that is a little bit complex, so it's not something we would be adding to SerilQL directly. But yeah, definitely working with arrays and working with objects needs to be as easy as possible and performant in SerilQL. So we'll be looking to merge your PR this week, hopefully, once we've merged some of the stuff to do with live queries. And I hope that answered your question. If you've got any other questions regarding that, then let us know. Zafar, welcome to the stream, Zafar. Zafar's asked us whether JavaScript functions can be used with SerilDB.wasm, the WebAssembly library. And is it true that they can't? So unfortunately, at the moment, the JavaScript functions can't be used with WebAssembly library, purely because under the hood we're using QuickJS, and QuickJS doesn't compile down to WebAssembly easily. I know there are libraries out there that have managed to compile it, but we want to do that in a good way, let's say. So we do intend to have most of the functionality from SerilDB supported across the deployment, whether that's WebAssembly or single node or in the server. So we are hopefully going to be moving towards that path where SerilDB JavaScript functions can be used within WebAssembly, but it's not quite there just yet. I guess my question to you, Zafar, is for the WebAssembly library, where do you envisage using it? Is it server side or is it in the browser? Because that could we've got some other plans around Node and Deno support, which may mean that we can actually run JavaScript functions inside those libraries. So it's a question from Sophia again. Is there planned support for JS lambdas? So in the future, we'll be able to pass JavaScript functions as values, say, to SerilQL functions. I'll let Misha answer this. So Misha, you've done a lot of embedded JavaScript function hacking. What regards to lambdas and things like that, what are your thoughts around that, and what is the closest you've got to that so far?
Well, it would be very cool, of course. Let's put it that way, first of all. So the closest you can currently get to a thing like that is with the custom functions. So you could define a function which then returns a JS function in which you have a JS body. So yes, so you could define a function, and I think that there will be some improvements coming to the way that permissions work for these functions. So you could, for example, let the function execute as a scope user or as root or stuff like that. And at that point, you could actually use it as sort of an API endpoint. I'm not sure, but yeah. So sort of in a sense like that, where you can also modify data.
Yeah, it's interesting. Sophia, if you could go into a little bit more detail about how you could imagine using those lambdas within SurrealQL. Obviously, we do want to make SurrealQL have a lot of this functionality with regards to processing of arrays and objects. So it's definitely something we want to add. Misha, I'd love for you to talk a little bit, because there's a question here from Wolfer, which is, are these libraries already prepared for the soon-to-come live queries? And I know you've been working on that. So yeah, go. Let us know how the live queries work when they're released with the libraries.
So the JS library actually added back to a support for live queries in the last update. It was already in there a few updates ago, but I removed it because it was basically an implementation based off a single Discord message. And I was completely refactoring everything, and I wasn't sure how it was going to work, so I removed it for a bit. Then in the last update, we in the last update we implemented it back into the JS library, with hopefully soon also other libraries. I'm not sure about WASM. I think it will be in WASM already, right? Because it's essentially the Rust API, so it should be in there.
Yeah. So regards to live queries in the Rust API and in the therefore WebAssembly API as well, those will all be supported already as soon as the live queries are introduced into our next beta. So definitely the JavaScript, TypeScript, WebAssembly, Rust, and then maybe not immediately, but Python and Golang and Java in due course as well will support the live queries support. So yeah, so absolutely. We've got a question here from Vitor. It's not quite JavaScript related, but it is about SurrealDB Cloud, and when is it? So we don't have an exact launch date for that, Vitor, but we're working hard on it. We're working hard on many different features in terms of scalability, security, the monitoring of that cloud as well. So yeah, so no exact date yet, but what I would say is, if you're in London in September, early September, September the 13th, definitely sign up to come to our SurrealDB World Conference. We've got a lot of exciting announcements there. Otherwise, we'll be streaming that live online as well, and it will be available after as a recorded session. So we're going to have lots of exciting announcements and new things announced. So definitely, if you can join that, go to surrealdb.world, surrealdb.world, and sign up there. So, Misha, do you have anything else you want to demo at all with the WebAssembly library or with the TypeScript libraries?
I would surely like to come back to the question of Sophia, because I think I misread it a bit. You can actually already pass on JS functions as SurrealQL values. That's already possible right now. So you can, for example, indeed use a SurrealQL function and just pass a JS function through, which will do something, whatever you want it to do, and it will return the value, and that will be the value passed to like that argument of the custom function.
I think what we're going to do, Misha, is get you to quickly hack it up on a playground instance.
Can do it.
And let's see how easy it is to do. Let's bring up his screen. This is a test.
So let me quickly.
So Sophia's said Misha was kind of. Let me bring that up. There you go. So what Misha is going to show you here once he's logged in is kind of some of the more fun / advanced functionality you can do with the JavaScript functions. But definitely with array for each and then v+1, it's not going to be very performant, because obviously invoking a JavaScript context and a JavaScript runtime for every single array value is not going to be performant. But it's something we want to have support for in CerealQL itself in the future, so that you can manipulate your data in that way as well. So hopefully in the future, in a future version, we're going to have a for query, which is moving towards that functionality that you have there, and then lambdas down the line as well. In the meantime, some of the more advanced the right word, Misha, or is hacky the right word? But some of the more advanced
both words.
Functionality that you can do with JavaScript functions, Misha will give a demo of here. Is there a planned date for CerealDB Software as a Service by Cifuentes MX? Not just yet. We've got some big announcements coming on September the 13th. I'll repeat that again. If you're in London on September the 13th, do come along to our CerealDB World Conference. You can sign up at cerealdb.world, and we'll also be streaming that online. We've got some big announcements, obviously some big releases, and some things that we haven't talked about, but we've been working on in the background. So it's going to be an exciting day. And then obviously CerealDB Cloud is what people are waiting for, so we'll be talking about that as well. So what Misha's doing here is on line 6, he's defining a function, which is a custom CerealQL function. It has typing support. Now, this was added into the last beta, but it's definitely had some improvements in this last version. Especially with regards to typings, which is tripping Misha up here a little bit. There you go. So he's taking a first argument, which is an array of numbers, and a number in CerealQL, just to clarify to anybody who doesn't know, a number can be an integer, a floating point number, or a decimal. So you can type it specifically with one of those types, or you could just say any type that is a number. Now, inside this custom CerealQL function, he's then returning a JavaScript function which maps over each of the values in an array and adds one. So let's see what happens here. So there you go. So using passing effectively the entire argument to the CerealQL function, which in turn passes it down to the JavaScript function, you can have similar effects. It's not quite lambdas just yet, Sophia, but it does have the same effect. So again, you can then, there you go. So you can pass different arguments in and have those returned. As Hugh said on CerealDB, there is a ticket giveaway at the moment for a fully paid for ticket to CerealDB. So just to make that clear, CerealDB World Conference is completely free to attend, online or in person, but we're giving away 3 tickets. The terms and conditions for that are available on the giveaway tweet. But yeah, so fully paid for tickets over here to come and attend CerealDB World Conference.
Okay, that should be it, I think.
So they're interesting. So a few complex things here which some people might not have used. You've got define function, which is creating a CerealQL function. So they're very performant, very quick. And then you've got the second line, which is returning a function. So it's returning the result of a JavaScript function. And that's going to be slightly less performant because it's spinning up a JavaScript context and JavaScript runtime, passing the objects into it over that that barrier between Rust and JavaScript, and then back again. But you can do some pretty complex and clever things with those. And if you have any questions about what you can or can't do with those, or if you've got issues, then jump onto our Discord. Always ask any questions you want, and we'll try and answer them as best we can. Wolf has asked, is there a specific reason why JavaScript functions only and not, for example, Rust functions as well? So if you could clarify what you mean, Wolfer, what do you mean exactly by that? In SerialDB or in SerialQL, you can merge JavaScript functions and Rust functions simply together. And we're also working on an improved performance and improved functionality of our JavaScript runtime itself. As Misha mentioned at the beginning, you can see one of the PRs by Mace recently to do with adding fetch support, so HTTP requests from the JavaScript runtime to external APIs. So if you clarify, Wolfer, what you mean exactly by that, we'll try and answer that better. I think while we're waiting for some more questions, I'll be really good to get Emmanuel up here. He's online, and just to talk about the recent PR that was merged to do with full text search, and what that means. I know we've got another stream in a couple of weeks' time to do with indexing, so let's not jump too much into it. But here is Emmanuel, and let's bring Emmanuel up onto the screen there to talk about the latest PR and what that means, what that's going to be leading to.
Yeah. So can you hear me? You can, right? Yeah, good. This second pair. So this is the second pair for the process of bringing full text indexing and search available in SerialDB. So there were a first pair that had been merged probably one month ago, which was mostly indexing. So what we bring now is the query planner. So it's not only about, by the way, the full text indexes. It's also about the normal indexes for normal values. So the query planner is this ability to analyze the select query, the where clause in the select query, and try to use the index if they are available for the field you are requesting of. So it's a first version of this thing. So we have a query planner that this query planner try to make an execution plan. This execution plan can be provided. You can add in the select statement an explain parameter, and then you are aware if the index has been triggered to execute the query. I mean, you may see it because it's supposed to be much faster, but it's a way to validate that it works. So yeah, so the query planner is here now. There is still 2 PR to go that are currently in review, and the full text features will be the first version because it's the beginning of a story, right? I mean, there is still a lot of things to do, but there is already something that you can use, and we will make a demonstration of the kind of application you can already use with this new feature. Yeah. So I think we have an event next Wednesday, right? When we are going to present that in the office in London. And beginning of July, I think we have a live stream presenting the feature, and it should be released. But
absolutely,
yeah,
that'd be brilliant. So just to make it clear, Avinash has said, can you share the link to the CodePen Misha was demoing? So we'll definitely do that. And just to make it clear, all of this full text search indexing is actually available inside the WebAssembly library as well. But also, if you're using the database as you would typically, connecting to it remotely, then you obviously benefit from traditional indexes and full text search indexes. So really exciting stuff with regards to the indexing in SerialDB. And Misha and Emmanuel will be on a future stream, I think a couple of weeks' time, talking about indexing, looking at how you would go about indexing web pages or text, and also bringing out those results with highlighting and things like that. So really exciting stuff. We can't wait to show you. In the meantime, we've got a question here from Wolfer, which I misunderstood. I think Misha probably got that right. Basically, so can we actually embed Rust functions inside CerealDB as opposed to JavaScript? So yeah, this is something we are going to be working on soon, effectively being able to add WebAssembly plugins or WebAssembly functions, as it were, to CerealDB so that you can add your own custom business logic and your own functionality. Maybe you don't want to have that running inside the database, or it's specific to your business or specific to your process. So that would be able to be added in easily to the database, not having to compile it into the database from scratch, but actually adding it in at runtime is something we want to have working. So Emmanuel, thanks for joining us today, and we're looking forward to that stream in a couple of weeks' time. Which I guess is going to be heavily based on the JavaScript library itself with regards to querying from the browser. So you'll see some of the things we talked about today in terms of WebAssembly, JavaScript, and the API connecting the two together in that future stream when we look at indexes with a specific kind of focus on full text search indexes. Let me just see now if I've got any questions I have missed. Excellent. I think we've answered. If there are any other questions, let us know. Otherwise, great to have you all here. This stream will be on YouTube, available afterwards at some point as well. And in 2 weeks' time, so 4 o'clock British Summer Time, so the same time in 2 weeks' time, we will have a stream where you'll see Misha and Emmanuel talking about indexing. So definitely join us if that is something that interests you. I guess it interests everybody, right? It makes the database faster, and that's what everyone wants. So who doesn't like indexing? We've got one last question from Sophia, so I'm going to wait for that to come through, and then we're going to say goodbye. I don't know how slow the connection to YouTube is. Let's wait for that question. Can you check about supporting Fermyon WebAssembly Cloud? So that is I'll come back to that question. How do I add WASM functions to run in the embedded JavaScript? So you can't run embedded WASM functions in the embedded JavaScript at the moment, Sophia. That is probably not something we're going to support, purely because those JavaScript functions embedded in the database are designed to be really quick, short-lived, as powerful, as performant as we can get them, but not designed to run anything really large or complex. So the WebAssembly functions will run separately. There'll be separate functionality for adding those WebAssembly functions into the database. They won't work through the JavaScript runtime. And then final question we've got here, which is, I'm interested in Azure. What are your plans for that cloud platform? So Azure, obviously, big enterprise cloud. We're going to support that down the line. We don't have exact timeframes for that just yet, orthodox forever, but we're definitely going to be looking to support that enterprise cloud platform. So
for the time being, for Azure, I think that you can also deploy Kubernetes clusters onto Azure, right? And we recently released a guide to deploy to Kubernetes. Although it is focused on a local development machine, you can, of course, also deploy CerealDB via Kubernetes onto Azure if you want to.
That's a great point. So jump into the CerealDB.com website, go to the docs page, and under the deployment menu on the left, you should be able to see the start of our guide section for deploying CerealDB in different environments. And one that Salvador added recently is on Kubernetes. So again, you should be able to run CerealDB on any cloud. It's not really linked to any one particular cloud. So you should be able to run that on Azure or AWS Cloud, but definitely we're going to be supporting these clouds with CerealDB Cloud Platform in due course as well. So Emmanuel, Misha, great to have you here, and thank you for your demos, your example, and your very quick coding there, Misha. And to the community, thank you for joining us. Thank you for the questions, and again, see you in 2 weeks' time for a stream focused on indexing and full text search.